Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting topic, which is called as LSTM. What exactly is LSTM? Where do we use LSTM? What are some of the advantages of using LSTM? Even before I proceed to talk about each of these points, may I request you to subscribe to my channel, also like and share my videos. Let me first talk about what is the agenda for today's video. In today's video, I'll be mainly focusing on 5 important points. The first is, what is LSTM? Secondly, we'll be looking at some of the important applications of LSTM. Thirdly, we'll talk about the advantages of LSTM. Fourthly, we will look at what are the disadvantages of LSTM. The fifth important point would be about the conclusion based on our learnings from LSTM. So these are some of the important points that I'll be covering in today's video. Let's begin by asking a simple question. What exactly is LSTM? What do we mean by LSTM? LSTM stands for long short-term memory. I repeat, LSTM stands for long short-term memory. It's a type of RNN. It can be used to process large volumes of data. LSTMs are a part of advanced recurrent neural networks. One of the main advantages of using the LSTM is that it can handle long-term dependencies. Further, LSTM has a remarkable ability to remember information for long periods of time. Let me clarify each of these points in detail. LSTM is a type of RNN or recurrent neural network architecture that is designed to address the vanishing gradient problem of traditional RNNs. Here are 5 important points that summarize LSTM. LSTM networks are used for modeling sequential data. Now, what exactly is sequential data? Typically, speech recognition. Speech is a typical example of sequential data. So LSTM can be used to model speech recognition, machine translation, and handwriting recognition. Secondly, LSTM networks use a memory cell and 3 gating mechanisms. The first gating mechanism is the input gate. Secondly, you have the output gate. And thirdly, you have the forget gate. These 3 gating mechanisms are used to selectively update and forget information from the input sequence. Thirdly, the memory cell is responsible for storing long-term information and passing it to the next time step. Fourth important point is the 3 gates allow LSTM networks to handle long-term dependencies, making them particularly effective in modeling sequences with long-term dependencies. LSTM networks have various extensions and variants, such as bidirectional LSTM, convolutional LSTM, and attention LSTM, which can further enhance their capabilities for modeling sequential data. With this background about LSTM, let's now proceed to look at some of the interesting application areas of LSTM. There are many different applications for LSTM. LSTM, as we have already seen, is a type of RNN architecture, which is widely used in various NLP or natural language processing tasks and other time series data tasks. Here are 5 points that summarize some of the applications of LSTM. The first being NLP tasks. LSTM networks are widely used in various NLP tasks such as language modeling, text classification, sentiment analysis, machine translation, and speech recognition. LSTM's ability to handle long-term dependencies and model sequential data make them particularly effective in NLP tasks. Let's now talk about the second important application, which is time series forecasting. LSTM networks can be used to model time series data and perform various forecasting tasks such as stock price prediction, energy demand forecasting, and weather forecasting. Let's now talk about the third important application area, which is handwriting recognition. LSTM networks can be used to recognize handwritten text, which is useful in applications such as digit recognition, signature recognition, and text recognition from images. The fourth important point here is music generation. LSTM networks can be used to generate music by learning patterns from existing music datasets. Further, this can also be useful in creating background music for videos, games, or other applications. Let's now look at the fifth important application, which is health monitoring. LSTM networks can be used to monitor and analyze health data such as ECG signals or electrocardiogram signals, blood pressure, and glucose levels. LSTM can help predict and diagnose health conditions, monitor disease progression, and personalize treatment plans. In summary, LSTM networks have a wide range of applications in various domains, including NLP, time series forecasting, handwriting recognition, music generation, and health monitoring. There are two additional points which I'd like to cover here. One underappreciated point about LSTM is that it can be used for text generation as well as anomaly detection. Now that we have looked at the applications, let's proceed to look at some of the advantages of LSTM. LSTM networks have several advantages over other neural network architectures. Here are 5 points that summarize the advantages of LSTM. The first important point is LSTM has a wonderful ability to handle long-term dependencies. I repeat, LSTM has several advantages as compared to other neural network architecture. One important point here is that LSTM has a remarkable ability to handle long-term dependencies. LSTM networks can handle long-term dependencies by selectively storing or discarding information from the input sequence, making them well suited for modeling sequential data. Secondly, LSTM can help in preventing vanishing gradients. LSTM networks use a gating mechanism to prevent the vanishing gradient problem that traditional RNNs often face. This allows LSTM networks to learn more effectively from long sequences. Third important advantage of LSTM is flexibility. LSTM networks can be used for a variety of tasks such as time series forecasting, natural language processing, and speech recognition. They can also be combined with other neural network architectures to further enhance their capabilities. Fourthly, scalability. LSTM networks can be scaled up or down to handle large or small data sets, making them suitable for various applications. last but not the least, interpretability. LSTM networks are relatively interpretable compared to other neural network architectures. The gating mechanism allows user to understand which parts of the input sequence are being used or ignored by the network. In summary, LSTM networks have several advantages, including their ability to handle long-term dependencies, prevent vanishing gradients, their flexibility, scalability, and relative interpretability. These advantages make LSTM networks a popular choice for various applications in machine learning and artificial intelligence. Let's now proceed to talk about some of the important disadvantages of LSTM. Like with any machine learning algorithm, LSTM also has its share of disadvantages. While LSTM can be beneficial, can be useful, and has several advantages, they also have some important limitations and disadvantages. What are some of the important disadvantages of using the LSTM? The first important disadvantage of using LSTM is computational complexity. I repeat, computational complexity, or it is computationally expensive to use a LSTM. Let me elaborate on this point. LSTM networks are computationally more expensive than traditional RNNs. It requires more memory to train and evaluate a LSTM model. This can be a significant limitation when working with large data sets or when training on resource-constrained devices. The second big problem of using LSTM is the problem of overfitting. LSTM networks are prone to overfitting when the training data is limited or noisy. This can result in poor performance on unseen data. The third big disadvantage is difficulty in training. Training a LSTM network can be challenging due to the complexity of the architecture and the need to fine-tune several hyperparameters. The training process can also be very slow, which can be a bottleneck in the development process. The fourth big disadvantage of using LSTM is a lack of interpretability. While LSTM networks are relatively interpretable compared to some of the other neural network architectures, it can still be difficult to understand how the network makes its predictions or decisions. Let's talk about the fifth big limitation or disadvantage, which is limited parallelization. LSTM networks are not easily parallelizable. At each time step in the sequence, as each time step in the sequence depends on the previous time step. This can limit their scalability and efficiency, particularly when working with long sequences. In summary, LSTM networks have several limitations and disadvantages, including their computational complexity, propensity for overfitting, difficulty in training, limited interpretability, and limited parallelization. These limitations highlight the need for careful consideration when choosing an appropriate neural network architecture for a given task. Let's now proceed to the concluding slide. In the conclusion, we'll be summarizing some of the important salient features of LSTM. LSTM is a type of recurrent neural network that is designed to address the vanishing gradient problem of traditional RNNs. So this is a good interview question. Why do we need LSTM? It is a useful technique to address the vanishing gradient problem of traditional RNN architecture. Secondly, LSTM is a very powerful and flexible neural network architecture, which is widely used in various NLP tasks such as text classification, machine translation, and speech recognition. Thirdly, LSTM networks are particularly good at modeling sequential data with long-term dependencies such as language modeling, handwriting recognition, and music generation. Let's now talk about the fourth point. LSTM networks use a memory cell and 3 gating mechanisms to selectively update and forget information from the input sequence. The gates are the input gate, the output gate, and forget gate. Fifth point, the memory cell is responsible for storing long-term information and passing it to the next time step. Sixth, LSTM networks are trained using backpropagation through time, or BPTT. I'll repeat this. LSTM networks are trained using backpropagation through time and can be trained using various optimization algorithms such as stochastic gradient descent and ADAM optimization. Last point is LSTM networks have various extensions and variants such as bidirectional LSTM, convolutional LSTM, and attention LSTM. In summary, LSTM networks are a powerful and flexible neural network architecture that can effectively model sequential data with long-term dependencies, making them a popular choice for various NLP and other time series data tasks. With this, I have come to the end of today's video. Before closing this particular video, I'd like to acknowledge that I have used one of the images from a website which is called as pixabay.com. So credit must be given where it is due. I'd like to thank Pixabay for making this particular image available on artificial intelligence brain. With this, I have come to the end of today's video. I thank you very much for watching this particular video. I request you to subscribe to my channel, also like and share my videos. Thank you very much once again. Have a great day ahead.